Hello everyone, my name is Mohammad Abdul Rahman. I'm a lecturer of physics at Al Bushra Private School in Isba, Oman. I have done my MPhil physics from Qaid University, Islamabad, one of the most prestigious institute in Pakistan. And also I completed my BA degree and the Bachelor of Education. I have 6 years of teaching experience in different institute, a 4 year in Pakistan and 2 year in Oman. Currently, I teach O levels and A level physics, a British curriculum, in Al Bushra Private School. So this is my contact number and this is my email address. So you can contact me anytime if you want. So today we discuss about projectile motion. In this topic, we discuss about the background of projectile motion, what actual the projectile motion is, and which type of motion is projectile motion, is which type of motion is not a projectile motion. We discuss each and everything in detail. Also, we discuss about the maximum height of projectile, time of flight, and range of projectile, which is mostly asked in your exams. They give you the data over there, and they can ask you that to find out the maximum height, the range, and time of flight in this particular topic. Also, we can do some type of simulation over there, so we can practically demonstrate that at what angle the height will be maximum, at what angle its range is a maximum apart, and at what angle the maximum height and range is equal. So we can discuss each and everything. Also, we discuss about the past papers, the question that asked in O levels and A level exam. So we practically demonstrate each and everything in this type of session. Right. So let's move apart. So first of all, we discuss about the projectile motion. Now you can see that here a person who kick the football, and this football is move apart just like this one thing. And when he kick this football, this motion, they can move apart like this thing. So this actual motion is called projectile motion because this motion is two-dimensional motion. If we divide this motion, so we can say that we have X component and Y component. So this two-dimensional motion is actually called projectile motion. So one of the question apart, they can ask you that if I drop this football from a certain height and it moves just like this thing, move a straight path. Is this motion is projectile motion? You say, no, this motion is not projectile motion because this motion is one dimension motion. Here, the basic condition of projectile motion is two-dimension motion. All right. Any motion which is two-dimension motion is projectile motion. Similarly, if I take the aeroplane over here and this aeroplane is moved apart like this thing, and some person asked that this motion is projectile or not. So you can say, no, this motion is not a projectile motion because this is a one-dimension motion. So the basic condition of projectile motion is two-dimension motion under the action of gravity. If someone asked you about the definition of it, so the simple definition is the two-dimension motion of a body, motion of a body under the action of gravity, under the action of gravity is called projectile motion, is called projectile motion. All right. So the two-dimension motion under the action of gravity is called projectile motion. All right. Now let's move for some of the examples, daily life examples related with this projectile motion. Move apart. So there's many examples over here. So we can discuss the practical example of this projectile motion. All right. So let's move apart. The second thing is yes. So you can see that here are some examples of projectile motion. The first example is we see that we have an aeroplane over here, and this aeroplane is moved in a straight line. If someone asks you that is the motion of the aeroplane is projectile or not, so you say no, this is not a projectile motion because this aeroplane is moving in a straight line. But if this aeroplane drops some of the gift from there, and you can see that this gift is moved in two-dimension motion. So this motion is projectile motion. The same question they ask, why this gift not drop in a straight path? Because the reason is that when this aeroplane is moving, and this gift which is placed inside the aeroplane is also moving like this. So when we drop this gift from that certain height, so it cannot move in a straight path. So it can move just like this projectile motion. All right. So that's the reason behind it. The second example is the cannon. So you can see that if we fire the ball from the cannon, this also move in two-dimension motion. So we can see that, yes, this is a projectile motion. And the third example is you can see that if a bowler ball in front of the batsman, so when he fall the ball, this motion is also a two-dimension motion. So we can say that, yes, it's a projectile motion. All right. So the basic thing that we discuss in this projectile motion is actually the maximum height, the range of flight, and time of flight. All right. So the most important thing in this projectile motion, we discuss the range of projectile. What is the range? The range is when we see that if we pick the ball over here, and if we kick the ball from that point A, and this ball is moved apart like this, and it move at a certain height, and then they drop the ball, so the dist and drop at point B. So the distance from point A to point B is, we call it a range of projectile. All right. So this is the range of projectile. The second thing is height. So from the maximum point height to the ground, so we can say that this is height h. All right, which is denoted by mostly h. And the third thing, we can find out the time of flight. This is a time of flight. Here we have three equations that we use, actually six equations that we use to find out the projectile motion. What types of equation that we use? The first equation, the equation of motions, is the first equation, second equation, and third equation of motion. The fourth thing is the equation of maximum height, time of flight, and the range of projectile while solving this type of numericals over here. All right. So first of all, we discuss about the equation of maximum height, time of flight, and range of projectile. So this is the equation of maximum height. That is h is equal to v square sine of square theta divided by 2g. Here v is the initial velocity and theta is the angle which is between them. The initial velocity, at which velocity that we throw the ball, and g is the acceleration due to gravity, whose value is 9.8 meter per second. You must remember one thing, that if the ball is moved in a upward direction, the acceleration due to gravity is, we can write minus g. But if the ball is moved in the downward direction, so acceleration due to gravity is plus g. All right. The second thing is time of flight. The equation of time of flight is 2v sine of theta divided by g. Here v is the initial velocity. One thing you must remember, that if we increase the velocity, so maximum height is also increased. Similarly, if we increase the velocity, time is also increased. Here now we discuss about some of the simulation problem which is related with the practical life examples, and we can discuss each and everything. All right. So the first thing is, now we discuss about the simulations. Yes, share about. Yes. Look at this one of the simulations over here. The first thing is, we can see that we have a cannon over here, and if we take some certain angle over here, and now initially the velocity is 10 meter per second. And if we drop the cannonball over here, and this is the our range. All right, so we take our range is 10 meter. All right, but if we increase the velocity 16 meter per second, for example, now you can see that the ball is moved very far away from each other. So before that, we discussed that if we increase the velocity, so our range is also increased, time is also increased, and maximum height is also increased. For example, if we take this thing, you can see that our time of flight is 1.5 second, the range is 10.9 meter, 09 meter, and the height is obviously 0 right now. But if we increase the velocity, now the time is 2.46 second, the range is 25.84, and height is from this time. So you can find out the height over here. And the second thing is, initially, if we take the velocity for 10 meter per second for all the cases, now look at these things. Now here the angle is 49. Now we discuss about at what angle the range will be maximum. All right. For example, if we take the angle of 49 degree, so you can see that this is our range. All right. If we increase the angle of 73 degree, you can see that our range will be decreased. If we lower the angle of 30 degree, our range is also a little bit increased. Now we can find out at what angle the range will be maximum, and that angle is 45 degree. For example, if I take the 45 degree over here, yes, 45 degree. Uh, uh, yes, yes, 45 degree. Now I can find out the range. Now here the range is approximately 10.3 meter. Now we also take different angles, 61 degree, our range will be decrease. If I take the angle of 25 degree, our range is also decrease. If I take 77 degree, our range is also decrease. So at 45 degree, our range will be maximum. So we can see that at the angle of 45 degree, the range will be maximum. This is the most important MCQs that mostly ask in your exam. So you must remember this thing. All right. The second thing is at what angle the maximum height and range were equal. So I can find out at which angle, well, we can say that the maximum height and range both are equal. All right. So we can find out and that angle is 76 degrees. So you can see that here is a 76 degree. The maximum height and range were equal. I can a little bit increase the velocity 16 meter per second. So you can see that here, this is the range of projectile. Now you can see that here the range is 12.25 meter. Is actually the height is also 2.5 meter or not, so we can find out the maximum height. So you can see that if I put over here, the higher height is approximately 12.25 meter. So you can see that our range is also equal 12.25 and 12.28. Approximately both height and range were equal at the angle of 76 degree. So this is the same MCQs they can ask in your exam, that at which angle both height and range were equal. So you must know about it. Now we solve one of the practical example related question over there. Here first we see that if we increase the velocity, so our height will also increase. But we can do it by using simulations. So we can already discuss these things. All right. And the second thing is, if we increase the velocity, range is also increased. We can also discuss previously. Now, let's move to the practical example, the question that mostly asks in your exam. But before that, we must know that which type of equation you must use while solving this type of numerical problem. The equation is equation of motion. We already discussed that we use equation of motion to solve this type of numerical problems. The equation is S is equal to VIT plus 1 by 2 AT. This is the second equation of motion we can particularly use for this numerical problem to solve this of question. The question is, the diagram below shows two different rifles being fired horizontally from the height of 1.5 meter. He says that here we have two rifles and whose height is 1.5 meter. So you can see that this height is along y component, not x component. So here y is 1.5 meter, all right, above the ground. Assume that the air resistance experienced by the bullet is negligible. So here's no air resistance over here. All right. The second part A is a rifle A is fired. The bullet has the horizontal velocity of 430 meter per second. Now this is the tricky part of this question. He says that if we fire the bullet from here velocity is 430 meter per second. Now tell me, is the velocity is along x component or y component? Obviously, you see that here the velocity is along x component, not a y component. If the x component velocity is 430 meter per second, so the y component of velocity is 0. Here the velocity is 0. Also, we know that when we fire the bullet, so it can move just like this thing. All right, so it can move in downward direction. And we already discussed that when the ball is moved in downward direction, so the value of G we take is minus 9.8 meter per second. Similarly, if the ball is moving in upward, sorry, plus 9.8. If the ball is moving in upward direction, we take minus 9.8. If the ball is moving in downward direction, we take plus 9.8 meter per second. Now solve the numerical problem. Here we can see that we can find out part A, calculate the time. Here we can find out the time. We can find out. How we can find out this type of numerical? So here the time is we take along the y component because the ball is moving apart just like a y component. So we can take only the y component of this equation. So by using this, so by using s, we can write y instead of x as. So y is equal to v I y t plus 1 by 2 a y t square. This is the basic equation. We must know about it. Now put the value and you can easily solve this type of numerical. So initially we see that vy is 0. So this term is obviously 0 and put the value. So y is equal to 1 by 2. Here ay is t square. So here t is equal to 2y divided by g under the root. Putting the value, so t is equal to square root of 2. Here y is 1.5 meter and the value of g is 9.8. So we can just calculate it and you can get the result over here. All right. The second part is calculate the horizontal distance traveled by the bullet before hitting the ground. Now we see that we have uh, horizontal. Now we find out the horizontal distance. The horizontal distance is along x component. So two things is given. We have velocity vx and we also have time. So what is the equation of horizontal component? We see that s is equal to v x into t. You just put the value and you can find out the horizontal distance. Here s is the range and the value of vx is 430 and the time period that we can find out from this equation, we can just put the value and you can find out this equation. All right. And the last thing is rifle B is fired and bullet emerged with a small horizontal velocity. He said that we have also the rifle B, which is also with fire with a small horizontal velocity. For example, if we take the rifle B velocity is 400. Explain why the horizontal distance traveled by bullet B is less than bullet A. He said that why this horizontal distance of rifle B is less than rifle A. So we see that our range is, the formula for range is R is equal to Vx into T. Here we can see that if the velocity is decreased, so range is also decreased. All right. So this is the logic that you can give in your exam, that here the range is decreased, velocity is decreased, so our range is also decrease over here. All right. So this is a simple question that can ask in your exams. Uh, Ross, I want to thank you very much for listening my lecture. If you have any question regarding this topic and any type of confusion, you can ask about me. All right. Thank you very much.